Okay, ladies and gentlemen, so now here's question 3. The question says, is each relation linear, quadratic, or neither? Explain how you know. So we're going to take a look at each one. Look at this. It's got a 2x squared, a 3x, and a 1. This 2x squared, that's the magic term. That's the quadratic term. When you have something like that, you know that it's going to be quadratic. And how do I know? Because of the 2x squared term. That's what makes it quadratic in this case. Take a look at this one. I don't have a x squared term. The largest degree I have there is a 3x. That makes this linear. It's in the form y equals mx plus b. There's no x squared term, so that is definitely linear. And this one, well, this one doesn't look like y equals mx plus b. That x is up in the top. And it certainly doesn't look like ax squared plus bx plus c. It doesn't look like this one. It doesn't look like this one. So it's not linear. It's not quadratic. We better call it neither. And that one is neither quadratic nor linear. It's in fact going to be exponential, but we'll talk about that in grade 11. The next one. Here is equation 2. Here's equation 1. Equation 1 is a line. Equation 2 is a parabola. Well, guess what? Lines get made from linear equations. How do I know? Because it's a line. It made a picture or a graph of a line. The next one is quadratic. Number 2 is definitely quadratic. How do I know? It made a picture or a graph of a parabola. A U-shaped curve, either opening up or opening down. Those are parabolas. All right, the next 3 examples are table of values. We're going to have to figure out whether it is quadratic, linear, or neither using the tables. Now, if you wanted to, I guess you could graph them and see what you come up with, but I'm going to use first and second differences. Now, what I'm doing is I'm saying, what does it take to go from -2 to -1? The difference is +1. From -1 to 0 is +1. From 0 to 1 is +1. From 1 to 2 is +1. So now I'm going to use the same thing. This is called my first differences. What does it take to go from -4 to -3? Well, it took +3. Do you agree? To go from -4 to -1, I had to go +3. And to go from -1 to 2, I had to go 3. I had to go 3. I had to go 3. Now, that's one way to think about it. The other way is to do the actual algebra. The algebra says to take y2 minus y1, in which case you would take -1, because that's the y2, subtract, because that's in the equation, the -4. So it would be -1 plus 4 is +3. You can do all of that work to get that answer, or you can do it my way and it's a little bit faster. So what does that mean? All of the first differences are the same. They're all the same. All first differences are the same. I don't care what they are. The fact that they're 3 is lovely, but I wouldn't care if there were 5, 7, 8, -2, whatever. The fact that they're all the same means this is linear. It has a constant rate of change, doesn't it? It has a slope. Constant rate of change. And if you wanted to go farther, which you certainly don't have to, the slope is the delta y over the delta x. It's actually going to be 3 over 1. So this particular line has a slope of 3. But that's probably 2 or 3 units ago, and the question's not asking us for that, but certainly we should know that. So the next example. Well, again, I could graph this if I wanted to, but that seems kind of useless. Why not use the information that they're giving me? So I'll take a look at the differences. To go from -1 to 0, I got to go +1. To go from 0 to 1, I got to go +1. I got to go +1. I got to go +1. So all of these are +1. What did it take to go from 16 to 2? Well, it took -14 to do that, didn't it? That's a pretty big jump down. What did it take to go from 2 to -4? Well, take away 2 gets me to 0. It took -4. What about to go from -2 to 4? Well, that took 6. What about to go from 4 to 20? That took 16. And what about to go from 20 to 46? That took 26. Wow. That's my first differences. So my first differences are 14, -4, 6, 16, 26. They are not all the same. No, 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 no. Definitely not the same. So guess what that means? It means one thing and one thing only. It's not linear. That's all it says. This is not a line. So, not linear. A fancy way of saying that is to say it is non-linear. That's just a way of saying it in a nice way. You know how if you say it's not linear, you're excluding. But if you say, well, you are non-linear, well, that's so much nicer. Looking up here. So what we do now is we look at our second finite differences. So we do the same thing, just with our first difference values. So the question is, what did it take to go from -14 to -4? It took +10. And what does it take to go from -4 to +6? 10. What does it take to go from 6 to 16? 10. And from 16 to 26? 10. These are what we call the second differences. And lo and behold, they are all the same. So if they are all the same, this is quadratic. That's the definition of being quadratic. Now notice you have to do this one first. You have to show me that the first finite differences are not the same. Then you do the second one. Well, that was fun. Let's do the last one. So, what does it take to go from, I'm trying to choose a different color here. How about black? What does it take to go from 0 to 1? +1, +1, +1, +1. So the first differences, what does it take to go from 4 to 12? 8. 12 to 36, 24. 108 to 36, this is getting hard. So 108 subtract 36, 72. And 324 subtract 108 is 216. So those are my first differences. Are they the same? No. What does that mean? Not linear. That's all that means. Let's do the second finite differences. What does it take to go from 8 to 24? Well, a fast way to do that is 24 minus 8, 16. What does it take to go from 72 or 24 to 72? Take 72, subtract 24, 48. And 216, subtract 72, 144. They're not the same, so guess what? It's not quadratic. And after that, in grade 10, you're not responsible for anything more. If it's not linear and if it's not quadratic, we say that it is neither linear or quadratic. And that's all you're responsible for in grade 10. Now, when I see you in grade 11, we'll have some more things to do. But right now, that's good enough. We'll pause the video there and we'll be right back.